Okay, in this video, going to learn how to start using MySQL Workbench to run some SQL statements. Okay. During this module, we'll only be working with single tables at a time, similarly to what we did in Module 7 with relational algebra. Okay. And then next module, we'll go ahead and look at how we can start using multiple tables. Okay, before we get going, I would like to make sure that you've downloaded this SQL Handout and these two files here. This contains the SQL to build the company database and the MyGuitarShop database. So download those three files and then we can get started. Okay, I want you to go ahead and open MySQL Workbench, and you should see a screen similar to this. Now, you may not have two of these boxes here, but you should see this local instance. Okay? So if we double click that, this is going to take us to the part of Workbench where we can start working on SQL. And I have some queries already loaded up here, so let me just close those real quick. Okay. You should have a screen like this. Now, it may not say SQL file 4 because I had some things open. It might say query 1, okay? But the name of the tab is kind of immaterial. Okay? But this is what you'll see. Okay? Now, first thing I want to do is go ahead and take that code that I had you load up. Right? Got two SQL files. I will caution you, never double-click a SQL file to open it in MySQL Workbench. Either copy and paste as I'm going to do, or you can do a file open SQL script. Both of those are okay ways, but if you have a file association on your computer set up to open a SQL file in Workbench, you will open in what we call an unconnected state. You will not be able to run any SQL statements because you will not be connected to the database server. So you need to either open the SQL files from within Workbench, or, as I do, I open them in Notepad++ and then just copy and paste. Okay, so let's go ahead and build the company database now. So I'm going to select all of this, paste it over here, and hit run. So I hit run. Now that's going to go ahead and build the database. Now, if you noticed, company database was open before, but now it's not here. We don't see it. Okay. To be able to see it, this little icon here, it's two little arrows pointing at each other. It kind of almost looks like the yin-yang symbol. If you click that, that refreshes, and there the company database is. Okay? Now this works similarly to how File Explorer works on Windows. If you click this arrow, we get a drop down. And we click an arrow here, and we can see the different tables. Now just clicking on these tables, I like to have it open like this whenever I'm writing code because I don't always remember the name of the attributes, and I can easily just click down here and find the attributes. Okay. So now we've built the company database. Let's go ahead and open a new tab for SQL, and that's right up here. Okay. It says SQL, and it has like a little plus sign on it. So if we do that, we get a new tab. The old tab is still there, but there we have the new tab. So I'm going to get the MyGuitarShop SQL, and I'm going to paste it, and then we'll run it. Okay, as before, the MyGuitarShop that I had is gone. I hit the little refresh symbol, and there's MyGuitarShop, and it has all of its tables in it. Okay, so now we have the two databases loaded up. And I'm just going to go ahead and close these tabs since we won't be running those again anytime soon. And I'll just open a blank tab now. All right, so yeah, we've got them all here. Now, if you we'll be doing a few adds, deletes, and updates throughout the next 2 weeks. So if you do happen to mess up one of the databases, all you have to do is take this code and run it again, and you'll recreate the database back in the original state. So don't be afraid of trying to play around with stuff because you can always recreate the database, no problem. So I want to show you a little bit about, you can see the schemas over here. Now you might have to tab around. There's also an administration tab here. One thing to check is this server status. When you click it, you should see a green arrow there. If you don't see that green arrow, you won't be able to run your queries. More than likely, you don't have the MyGuitarShop server run, or not MyGuitarShop, the MySQL server running in the background. So you need to make sure it's there and it's been started up. If it's not started, you can come here to Startup Shutdown, and it'll say Start Server. It'll have in red something like Not Running. Then you can hit Start Server, and that should bring it up. If it doesn't, you may need to install the server to get that to happen. Okay, so I'll close this administration tab and then click on the schemas. Now you won't have near the schemas that I have. I've loaded a bunch up here for different reasons, but you should at least have company and MyGuitarShop that you can see. And I showed you how you can hover over it or click on a table, see the attributes that are inside of it. That's kind of useful. Now there's also, when I hover, we've got three icons here. The one to the left looks like a little information symbol. It's a little eye in a circle. Then we have a wrench, and then we've got something that looks like a spreadsheet. So if we look at the information one, I clicked it, this shows us some information on the table. Now I don't find this particularly useful for this class because there's a lot of stuff in here we just don't need. Well, we can see the columns, indexes we don't need now. There's no triggers. There will be a foreign key. I'm not sure why it doesn't share here. You know, just things we don't need. You can actually see the DDL that would create the table. Okay. So that's somewhat useful, but not really. This wrench symbol is useful. Okay. It shows you a screen that you should be fairly familiar with. This is a similar screen to what you were using when you were completing your ERDs. Okay. If you want to see the foreign keys, see that foreign key, and you can see there's a foreign key that is created just like you all did in your ERDs. So this I find pretty useful. You can see the constraints on the columns, and you can see just various information. So that was the middle one, the ridge. The icon that looks like a spreadsheet, if you click it, that shows us the actual data that's in the table. And there's the data that's in the department locations table. So those three little icons, especially the last two, the two to the right, can provide you some useful information as you're writing your SQL. Okay. Well, and we've seen how to open SQL tabs. You just click this icon over here that's got the SQL with a plus sign on it. We do that. Now, if we want to run a command, I'm just going to write a simple one here. I'm going to select all the attributes from I'm typing as I'm doing it, from the employee table. Now, need to make sure before you run something you have the correct database selected. Okay, and in this case, I'm going to right-click on company and say set as the default schema. I do that, I can go ahead and run it. If I didn't do that, you'd get an error message that it can't find the employee table. So I'll go ahead and run this now. And to run it, I click this little icon that looks like a lightning bolt. And that will run everything that's here. If I would just select, and I might do this while I'm demonstrating SQL, I'll say, look at this. I'll try to run that, and it only tries to run the word from, which is not a valid SQL command. So that may happen to you if you're highlighting things and then click run. So just make sure nothing's highlighted when you click run. Okay. A couple more things I want to show you about how to use this. There are these three icons in the upper right. I usually have this right one so it's gray. If I click it, it'll turn blue, and more than likely you'll have the contextual help tab shown. Okay. To use that, you can just click on something. Now you may need to click this toggle button here to actually toggle it on. But then you'll see information that's pretty much just like in the help sheet for in the reference manual, for MySQL. It gives you a little bit of information. These things you can click and get more information, I think. Now there's the union, so you can go back and forth and you can click it around kind of like a web page. So if you don't want to see that, you can always change the size of the window by dragging, similar to most applications. But this icon can turn that off, so you don't see it. You can turn it back on, turn it off. Likewise, down here at the bottom where we have this action output. Well, one thing I'll say is make sure you clear this fairly often. All you have to do is right-click and clear. Because I've seen students that they've made a mistake in the query, correct it, but then they're chasing ghosts because they didn't clear the output and they're scrolling back and seeing the same error message, but it's not from when they ran the query when it was corrected. It was from before, and then they waste a lot of time thinking they didn't fix the mistake. So if you get a mistake and fix it, right-click in this output and clear. That might save you a lot of time. If you don't want to see the action output, you can go ahead and turn it off. Or really not turn it off, hide it. And then you can bring it back. Likewise with the schemas over here. If you don't want to see these things on the left, you can turn them off. Or display them. I guess it's not, again, hiding and displaying, not turning them off. And then the final thing I want to show you is how to reverse engineer a database. Okay? And I would recommend that you, especially next week when we get into the multi-table queries, that you reverse engineer whichever database you're working on. And what that will do is take the database that, one of the two databases we just installed, and it'll create an ERD from it. Okay. To do that, it's actually pretty simple. We do database, we hit reverse engineer, and this is the window that pops up. Now there's not too much you're going to have to enter here. Nothing on this first screen, nothing on the second screen, and on this screen you need to check just the schema that you want to build the ERD for. And I'll do the company database. I hit next, and then next, execute, and then next and finish, I believe, here when that's done. Next, finish. So there created a ERD for the company database. You can move this around however you want. It's fairly, this is what you did previously with the ERD you created. And you can move that around however you want. Now, like I said, for next week it'll be important because now you can find the primary key, foreign key, and just like in relational algebra, that's what's going to form your join conditions in SQL. Okay. All right, so we reviewed how to use MySQL a bit, how to run commands. We loaded up both databases and showed you how to go ahead and create an ERD to reverse engineer a database. Now we're going to take a peek at the DDL commands used to create the company database. Okay, now I want to review the DDL statements, the data definition language statements used to create the company database. Okay. Now this won't be testable material, at least the DDL portion. We'll get to some insert statements, and insert is a DML statement, or a data manipulation language, which is something an application program would use, so it is testable. But the first part, creating the tables, isn't. Okay. The reason I don't spend a ton of time on this is y'all have done the hard work about creating a database already. You've taken that order form and made tables out of it. You took the company database and made an ERD out of it. And I showed you how to reverse engineer a database into an ERD. You can also take an ERD and forward it and engineer it into the SQL you need to create a database. So actually writing the SQL to create a database is somewhat trivial if you can do the rest of it. And it's something an application program probably isn't going to do very often, if ever. It's more of an administrative task. So let's look at these statements. Okay. The first statement I have there says drop the database if exists, and then the company, the name of the database company. Now, if you all would look at your action output in Workbench, you'll probably see that this statement might have generated a warning for you because you didn't have the company database. So it would have been a little yellow triangle, I think, something that looks like that. For me, I didn't get that because I already had the database on my computer and I just dropped it. And dropping basically means that you delete it. Now I want to show you what this looks like in the reference manual. So I'm going to go to MySQL drop. And then we'll look and see how to read this in the, oh, that's drop table. I don't want to drop table. I want to drop database. Here, that's W3 schools, drop database. We can go here and then make sure we're in the right version. So here's the drop database statement. Not a very complex statement at all. I want to go over how to read the syntax though in the reference manual. If you hit curly braces, that means that, well, the words that aren't in curly braces are required. Now inside the curly brace, you're usually going to have this pipe symbol, and that's an OR. So you either have to have the word database or the word schema. Not both, just pick one of them. And then when you see square brackets, that is optional. So the if exists keywords are optional in this statement. I like to use them though because, like you had an error and your script wouldn't have ran because you didn't have the database to begin with. Right? So this allows you to keep that drop database statement here at the top, and if there is no database, you just get a warning and you can carry on by using the if exists. If you didn't have the if exists and the company database wasn't there, then you would have got an error message. The next statement creates the database, and it's just a shell. Right? That's all it is. There'll be no tables in it, no nothing, just on the schema side, it would just say company with nothing underneath of it. Now this use company is useful and you can use it in multiple places. It sets the default schema. Similarly to how I went in here and I right-clicked and set default schema there, that's what you're doing. If you didn't do that, you would have to preface every table name with company or My Guitar Shop, whichever database that you're in. And most people don't like it that wordy, and it actually, to me, reduces the readability of your code. So that's why I have this use company on here. Otherwise, I'd have to have company.employee, company.dependent down there, so on and so forth. So I just say create table employee. Now I can do that. And this is going to create the employee table. Okay. This should not look too dissimilar to you. It's similar to the screen that you used when you were creating the employee table inside of MySQL Workbench in your ERD. You have the attribute names, you have their data types and sizes, and then any constraints that you put on them. Okay. It is possible to put a primary column, they call it a column constraint out here with a primary key. But I don't like doing that because I like putting it in the same place for every table. And if we had a composite key, you cannot use column level constraints. You have to use a table level like this. Okay. Then I give it the name of the, give it a name for that primary key constraint. Then you pick the attribute from this list up here that you want to be your primary key. And now we've made the primary key. Then there is a constraint we can do for the foreign keys. Okay? And as you know, the super SSN is a foreign key that refers, in this case, back to the same table and the social security number field. Okay? That creates that relationship, that recursive relationship that we saw in our ERDs for the employee database. Notice, though, I don't have the foreign key in here for Dino. Okay? Why do you think that is? Well, because I have to reference the department table, and guess what? The department table has not been created yet. So we don't have it to reference. And later on, down here, I have an alter statement right here. Alter table employee, and we're going to add the constraint for the foreign key. Okay? And it references the department table and the primary key over in the department table. Okay? So that's how we get that the foreign key in there for the deno. And then these other tables are built the same way. They go ahead. Now look at dependent though. Notice it only has a single primary key constraint. And if you remember, a table only has a single primary key. If it is a composite key like this, you put the attributes that make up the composite key within the parentheses. Okay? You don't have two primary key constraints because you don't have two primary keys. You only have a single one. And the attributes go within the parentheses. If it was made up of 3 or more attributes, I would just keep comma separating the attributes and adding them in here. Now this engine INODB, I've added that because of the installations on campus. They set the database engine to MyISAM usually, which doesn't allow foreign keys. It doesn't allow a lot of things. So I put it here so the tables are built with the right database engine. And we can just go through and all the tables are created there. Then we're going to get to the DML statement. Okay. Now we're going to look at these insert statements. Okay. If you notice, I have this set foreign key checks to 0. This is not uncommon when we are bulk uploading a lot of data. And the reason for that is, think about trying to just insert the employee. Okay. Well, we have a department number down there. Okay, so I got to make sure department 5 would be in the department table, but department 5 would need a manager SSN, but we can't get a manager SSN until we have the employees in the employee table. You know, and you just get so many dance steps involved with all the foreign key relationships, it'd be almost impossible, or it would be very lengthy to insert all that data. So normally when there's bulk uploads, you got to make sure you understand the data very well and that it's formatted correctly and that you have all the relationships, you know, where there's a foreign key in the other table or in the same table, you have the primary key. So that's your responsibility then to make sure everything's good. And then you can just insert data. So, and if you notice at the very end, I turn those foreign key checks back on. And the foreign key check is what is used to enforce the referential integrity constraint. Okay? And MySQL calls that a foreign key constraint. Okay? And we'll go into these insert statements in more detail, but you can see I'm inserting several rows at a time. I don't have a column list, so I have every single row, or sorry, every single attribute in the table. They have to be in the same order that the create table statement had. So if we went up and looked at the create table statement, the first attribute would be first name, middle initial, last name, social security number, birth date, on and on and on. Okay. And then I do that for all of the different tables. And that's how we get the data inside them. And like I said, we'll look at this insert statement in a little more detail as we're going through the SQL statements. Yeah. A couple other things I wanted to show though. If you remember in the works on table, that had null. Also, we had in the employee table, James as supervisor was null. Notice that that is not enclosed in quotes. It is an actual keyword. And you may have to use that in some of your SQL queries as well, like in a select condition. You would say, but it wouldn't be, you wouldn't use the equal sign. You would say attribute is null or is not null is how you would test for that. So that's what I wanted to review with you on the SQL needed to create the tables necessary for that company database. And if we looked at the My Guitar Shop SQL, it is very similar. We've got a lot of create tables there. We drop the database, create it, use it, create some tables, come down, it's a little bit bigger database. Then we alter the tables for some constraints we couldn't have added, turn off the foreign key checks, and then start inserting data. So it's a very similar similar format to what was used for the company database. Okay, next we're going to start actually looking at some of the retrieval commands and how we do them in SQL. Okay. Well, before we look at the queries, I want to go over this SQL handout with you. All right. And I'll cover it, but this is something you should be referring to as you write your SQL statements, this module and next module, right? Because it lays out a lot of the guidelines and my expectations about how you should write your commands. Right? Initially, I give you a slimmed down version of the syntax for the select command. If we would go to the reference manual here, notice when we were looking at the alter table, or the drop database I guess we were in, it's in a DDL, the data definition statements. The select statement is down here in the data manipulation statement. And there's the insert statement we just used. And here's the select statement. You can see it is a little more complicated than what we'll learn in just these next 2 weeks. So there's a lot more to it. But what I've done in this handout is just pulled out the clauses in this statement that we'll be using. Okay, and this whole thing is the select statement. Now I will talk about the select clause, which will be this. From table references are the from clause, the where clause, the group by, having, order by, limit. I'll refer to all of those as clauses. And we'll go through these SQL commands and we'll start seeing how these are actually used. One thing to remember though, this syntax shows you the order the clauses have to be in. So we'll be using from and where and group by, having, maybe all in the same command. You need to make sure that you have your clauses all lined up appropriately in the right order. Okay. Then a little bit of instruction here. Okay. When you submit your assignment, you're going to have a document that tells you what you need to do. You'll need to put a screenshot on there. And that's where I'm going to give you feedback through Canvas. You'll also need to put it in a .SQL file. And let me just show you what that might look like, something it'll look like here. It will be this. Okay? And you will type your statements in here. Okay, whatever the select is. Okay? What I'll do then is I will download this and I will copy this whole file, put it into MySQL and run it. Okay? Because all of this information is commented out. This slash star and star slash are how we begin and end block comments in SQL. And if you noticed, I have all the question numbers commented out. So you just write your SQL statements in between those comments, and you can run this too. You can copy this answer sheet into Workbench and just run your information from there if you'd like. Yeah. But you will need to have your SQL statement in here, and then you have to have a matching screenshot of it inside the docx file that has the assignment. Okay? If they don't match, you get a 0. I'll still give you feedback, kind of, because I won't know which one you're really meant to use and submit. So I'll try my best, but they need to match. Okay? And then I have style and usage here. Make sure you use this. That you follow this. There's a lot of stuff in here, and I'm not going to go over it line by line because some of it we haven't seen yet, and you'll just need to read this and make sure you follow it. You can always ask questions about it too if you're not sure, but read through this. Some of it won't make very much sense right now, but as we go along it will. And really pay attention to this not to do. This is where I see a lot of students make mistakes, and I've tried to give you some hints here about what not to do. Okay? So please make sure you have this handout handy before you turn in assignment 9 or 10 or the final, that you read through this, you evaluate your SQL statements against this to make sure you follow these guidelines. Okay, so that's it for the review of the handout. Now we'll actually start looking at some select statements. Okay, now I want to show you how to start using the select statement. We can actually just use the select statement without a table if we want. Not really terribly useful for me, but we could do something like this. I run that, and we get some output. Okay? So again, I'm not sure why we'd ever want to do that, but it is available there. Now, going forward, for most of the time, I want to go ahead and show you the relational algebra associated with statements. Unfortunately, this first statement of just listing all attributes in a table, we don't have the equivalent in relational algebra. So if I want to list all the attributes in the employee table, this statement here will return all attributes and all tuples. Okay? The select clause itself is where we do the projection. Let's go ahead, if we look at the handout here up at the top, this is where we project the attributes that we want to see. If we want to get all attributes, we just use star. The where clause and the having is where we do the select conditions. They're called where conditions in SQL, but this is the select conditions we were using in relational algebra. But this first statement, I don't have any one of those. I am just selecting all attributes and all tuples from the employee table. And there they are. That's everything that's in the employee table. Okay, let's look at another statement here. First, we're going to look at what it would be for, we want to do this. We want to list all employees who make more than 30,000. So, sorry, I put that there, jump down. Here we go. So this would be the relational algebra, okay, salary greater than 30,000, and we select star because we're not projecting any attributes, so we've got to list all attributes from the employee table, and then this select condition we're putting down here in the where clause. Let me go ahead and take that, and I'll move it over to Workbench, and we can run that. When we run that, there we get the 4 individuals that made more than 30,000. Okay. So there we're seeing the actual select condition used in the where clause. Now, if we want to actually look at listing all employee first and last names, let me copy it all over here, basically doing a project. This is what it would look like. Okay. Now, I don't do a select, so I'm not, what am I trying to say? Selecting any tuples, I'll list all tuples, but I'm only going to get the first name and last name. Okay, so for this, we can see list all employee names. There we're projecting them, and then we have them here in the select clause of the select statement. That's where the projection attributes go. So if I copy this over to Workbench and run that, instead of getting all attributes, now we'll just get the first name and last name. Okay. So far so good. Nothing terribly new and exciting, but we're going to keep getting a little more complicated as we go. Let's take a look now at where we can do the select and project together. All right, so we say list the first and last name of employees who make more than 30,000. So the first thing I do is do my select. Just normal relational algebra. I'm limiting the rows, and then I'm projecting the names from that. This is what it looks like together in SQL. I can move this over to Workbench, and now I had returned 4 rows before. Now this will return 4 rows. We don't see any of the other of their information though, but that's the 4 individuals that make more than 30,000. Now the next keyword that we have, let me insert a few pages here. Let me get to a new page. Okay. This doesn't have any sort of corresponding relational algebra. Okay? But we're going to use the distinct keywords. If I just did this, let me go over here. I want to list the dependent names. I can run that. Now we're going to get the dependent names from the dependent table. And there's 7 names there. Notice that Alice is listed twice. If I wanted to only get the unique dependent names or not have any duplicate dependent names, then I can use a keyword called distinct. Oh, spelled it wrong there, distinct. Okay. That now will list just the distinct names, the unique names. Notice there were 7 rows returned before. Now when I run this, I'm only going to get 6 rows returned. Why? Because Alice is only listed once. Alice is in there twice in the dependent table, but we only listed her once because of the distinct keyword. All right, the next thing I'd like to show you is what we do for generalized projection. So if we want to look at some generalized projection, here we're increasing the salary plus 10%. So we're going to show the first name, last name, salary, and salary increased by 10%. There we have the relational algebra to do it. This is how it looks in MySQL. Or in SQL, sorry. I'm going to copy it over to Workbench now, and we can run that. Okay. And there we go. Not a great name there yet, but we'll cover how. Well, I can just show you real quick, but we'll cover it later. We use the keyword as to do a rename. Then I could call it something like increased salary. Now if I ran that, because salary times 1.1 is just not a great variable name. So if I'd run that, now I get increased underscore salary, which that could be used as a variable name in whichever language that you were using when you made this, use the SQL statement to get data from the database. So whether you're in PHP or C++, Java, whatever it might be, making your database calls, you want these to be good variable names coming back. Okay? And that's the generalized projection there. Basically, we can do math inside that select clause. Next thing I want to show you is how to sort. Okay, sort the output. Let's see, if we go up here, here's this. So we've looked at the select from and where right now. Where is where we put the table reference. Where is we put that select condition or the where condition. The order by clause. This is how we can order data in our output. Okay, and we don't have that possibility in relational algebra. But we use the order by. By default, everything is in ascending sequence. Okay? So whatever you sort, the smallest value is at the top, larger value at the bottom. You can sort by several column names if you want. And each one can be sorted in a different order. But if you want it descending, you have to put DESC, and usually with ascending, it's just left off since it's the default. And you can do a with roll up, and we'll cover that later. So let's look at how we'd actually put this into practice. Here we go. We've got this. Okay. Here I'm sorting by first name, last name, or I'm listing first name, last name, salary. I'm projecting those 3 attributes from the employee table. I'm not selecting any of the tuples. There's no where clause. And then I use order by. So it's going to be an ascending order by salary. And if people have the same salary, then it'll be in descending order by first name. So if we run this, let's see what it looks like. Okay. So notice we're in ascending order by salary. 25,000 is first, 55 is last. We've got 3 people that make 25,000, and we can see they're in descending order. Joyce is first, then Alicia, then Ahmed. Okay? So we can switch the order within that block there that got together because of their salary. And that's how we do sorting. Some students will use group by for sorting. That is not the purpose of group by. And behind the scenes, group by does something totally different than order by. The results are the same, but group by is a more expensive statement to run. So if you use group by to sort your data, you will lose points. order by is what we use to sort data. So please remember that. In that SQL handout, down at the bottom, I even give you a hint there of what not to do. Oh, where'd it go here? Right here. Do not misuse any keywords. For example, using group by to sort data. We don't sort data with group by, we sort data with order by. And you just list the column or columns that you want to sort by. Really we've got a couple more things to look at here. The next one is going to be limiting output. And again, this doesn't have the equivalency, any equivalency in relational algebra. The limit by clause is right here. You may or may not have noticed, but if I run a statement, limit is already put on there by default. Okay? Here it's set for 500. You can set that however many max rows you want. And the reason it's here, it's kind of a safety guard. If you're working with a 1,000,000 row table and you mistakenly say list every tuple, that's going to be a lot of processing, a lot of output. So by default, MySQL sets a limit for you. Now you can change that limit. You can change the default limit. You can also change it per statement. Okay? And that's what I want to show you here. So, well, there, we looked at the limit. The offset row count is what we're going to look at, or you could do that, and it's not really used that much. We usually start with the offset and the row count. So, if we want to list the first 4 rows of the employee table, this is what it's going to look like. That's going to list the first 4 rows. So let me take this over and run this and see what happens. So as you know, we've been getting 8 rows back from the employee table. When we do this, we only get 4 rows back. Okay, and that's what the limit does for us. Now if we use the offset, then it's going to look something like this. If we want to list the 3rd row and the next 3 rows, we have it look like this. So that's our offset. Skip the first 2 rows, then we're going to start with the 3rd row and go for a total of 4 rows. So we'll get the 3rd, 4th, 5th, and 6th rows out. So let's run that command and see how it differs. Now the first employee listed should be Joyce. So let's make sure that's what it is. Yep, there's Joyce, and then we get the 3 individuals after her. So that's how we use that limit clause, and it's only to limit the output. But this can be useful if you're trying to find the min or max of something. You can limit, especially if you want to find the 2 projects with the most hours charged about them. You can sort by sum of those hours in whatever descending order, and then limit the first 2 rows, so you'll see the first 2 projects with the most hours charged to them. So that limit can be used in some creative ways. Okay, the rename, what we do with row in relational algebra, and I showed you briefly how we can do that with just as with a column alias. And this is a column alias. First name is a column alias here. Okay? We use as. I'm a big one on when I write my code, I like white space and I like to line things up. You don't need to do this. Okay, I would highly recommend it though, just so it's a lot easier to read. Okay? And what this statement is doing is implementing this statement. Here, employee is projecting the first and last name, then we're renaming it to first underscore name and last underscore name. Okay? So let's see this command in action here. And there you go. Notice the column names are different now. And that's what we did. If we wouldn't have had these, let me not erase that comma. If we just ran that, it's F name, L name. Okay, so those column aliases are what we use to do renames in SQL. Okay. Now I want to start talking about aggregation. Okay. And aggregation is done, we'll put we could have an aggregate function in the having. We can also have aggregate functions up in the select clause. So both of those clauses could have aggregation in it. Now, it's the same 5 what am I saying, functions that we had in relational algebra. So when we're doing aggregation in SQL, we have min, max, average, sum, and count. Okay? Same ones. All right? Now let's see how we actually use them. So let's look at average first. So what I'm going to show you here, that's going to list the average salary of all employees. I'm not grouping it by anything, so this is going to average across the whole table. Right? The SQL statement for that looks like that. And now if I want to run that, that's going to give me the average of all employees' salaries. That's what it is. Most of the time, though, we're going to want to do some grouping. So I want to show you a little bit here about how we can do some grouping. Go back over here and I'll paste it. And grouping, the grouping attribute, we also have inside our SQL statement. So here's a couple examples. Notice Dino right there. That's the grouping attribute. Here we put it in the group by clause. We're grouping by Dino. We're getting a list of the department number and the average salary. And the grouping by Dino puts all of the department number 5 employees together and takes their average. Then the department 4 employees takes their average. Then the department 1 employee takes his average, but it's the same thing. It's only 1 employee in department 1. Okay. So let's see how that works. That's what it looks like, and when I run this, now we get each of the department numbers and we get the average salary in each department number. Now, if we forgot the group by and try to run it, well, we actually get an error because we're saying that we've got a Dino up here, but we don't have that grouping attribute. And depending on how the defaults are set in the version of MySQL Workbench that you're using, this may actually run and you would get 1 row as output. You might have department number 5 and then the average salary of every employee in the department or in the whole company, which would not be what you want. So hopefully you'll get that error message that I have there that prevents you from doing that. Okay? But if you have a grouping attribute up here, it needs to be in the group by clause when you're using an aggregate function like that. Now I did have this with rollup, and let's see how that changes our output. So, well, let me run it again. There we can see our output. If I add with rollup, it's going to give us some grand totals, or in this case, the average of all employees. Notice it's got null there. Okay, it's not for any department, it's across the whole table. We're rolling up all the averages we had and take an average of them. And we could do this with sum. If we wanted to get the total salary, we just do sum. And then we can run that. And we get the total salary by department. And then with roll up, that's the grand total for the entire company. Okay. If I wouldn't have that group by or this, what do we have there? 281,000. I go ahead and run that. There's 281,000, summing the salary across all employees. Okay. So that's how we do aggregation. Okay. One last thing I want to show you here is pattern matching. Okay. And pattern matching is when we have, it's similar to regular expressions. Okay, let me just list the employee table here. So if we wanted to go and say list all the employees whose first names start with J, we have to create a pattern that MySQL will use to figure that out. Right? And there's no real equivalent in relational algebra like this, but let's just find that one. This is going to list all employees that start with the letter J. Okay? And notice the percent sign there. Let me go explain how that actually works. Come on, go over there. Okay. So this is the command I just pasted there. Now, the percent sign works by saying I want to have everything that has a J after, well, anything after a J. The percent sign means 0 or more characters. Could be any characters. 0 or more characters after a J. So if we had somebody with first name just J, it would match that. If we had JOE for Joe or John or Jane or whatever, it would match any of those names. So if I run this over in Workbench, it's only going to grab those employees who start with a J. Okay. We can also use that to find an ending character. So if I do it like this, okay, now I'm going to be getting the first and last names from employee, where we can have 0 or more characters before an E, but E has to be the last character. It's anchored at the end, just like J was anchored at the beginning up there. So this statement would list any employee whose last name ends in an E. So if I run up this, we have that, and I can run that, and there I have, well, Jennifer is the only employee whose last name ends in an E. Now, there is another pattern matching character we have, and it is an underscore. And this matches one character. Okay. Character can be any value, but it's just we use that as a character. So let's see how we could combine both of those, the percent and the underscore. We want to list the first and last names employee whose first name has an O as the second letter. Okay, so this underscore is saying there needs to be one character here. Doesn't matter what it is, one character. Then the next character has to match an O, and then we can have 0 or more characters after that. Right? So that's what we're actually saying when we write it like this. First, it's got to have a character of any sort. Doesn't matter. It can be an O, it could be an A, a J, a percent sign, whatever, a number, any sort of character. The next character has to be an O, and then after that O, we can have 0 or more characters of anything. We don't have to have any more. We could have as many as we want. All right? And it doesn't matter the value. So when I run this one, oh, I guess I don't want that first and last instructions there. That wouldn't run. We do this, and there we get John and Joyce. Those are the only 2 employees who have an O as the second letter. And give you one more example here. Right. This will be to list the first and last names of any employee who has an address in Humble, Texas. Now, if you remember, I'm going to just list all employees here, okay, and all the attributes. We have this composite attribute here. So if I want to find out who's in Humble, Texas, it looks like Ramesh is the only one. But what will I need to do that? I will need to write something that looks like, make sure I got it selected over here, this. So I have a percent sign saying I can have anything, 0 more characters before the word humble, 0 more characters after the word humble. This is definitely not as good as a regular expression, but it is an attempt to be able to find the folks that live in Humble. And if we ran that, there we see we got Ramesh out, because we have 0 or more characters before Humble and 0 more characters after Humble, but we do have Humble right there. And that's the end of the things that I want to show you about SQL right now. We're going to do some practice coming up, and when we do the practice, I want you all to, after I give you the problem, stop the video, pause it, try to work that problem out, and then start the video to see the solution. And that's it. Okay, now we're going to do a little bit of practicing. Okay. I'm going to give you a problem and I highly encourage you all to pause when I give you the problem and then try to solve it, then unpause the video, and then you can see the solution. Okay, so for our first practice problem, here we go. Go ahead and do this. Write a SQL statement to list employee first and last names as well as their birth date. Sort the list so the youngest employee is on top. So go ahead and pause the video and work on that. Okay, here is the solution to this one. We got the youngest employee on top by sorting the birth date in descending order. So let's go ahead and try another one now. Okay, and this is kind of a two-parter. I'm going to give you some relational algebra here, and I'd like you to just figure out the plain English for this relational algebra, and then write the SQL statement for it. And so if you want to hear the answer for the plain English, that'll be next, and then I'll give you a chance to pause to write the SQL. Okay, there's the plain English. So go ahead and pause again, and I will then show you the SQL. And there's the SQL that'll implement that. Let's try another one now. Okay. And think about the words you'll need to use to only list a location once. The keyword. So go ahead and pause. And here's the solution. That distinct keyword is what will only list the location name once if there's duplicates. Another practice problem here. Okay. Okay, so this one might be a bit trickier, thinking about how you're going to sort it, and then how you're just going to restrict the output to those 3 employees. Okay, so go ahead and pause it. And here's the solution. Okay, we're able to do this. We sorted by salary in ascending order, and then we limited the output to the 3 rows, which gave us the 3 lowest paid employees. Okay, let's go ahead and look at another problem here. Make sure you don't forget that part right there. So go ahead and pause and you can work on that one. And here's the solution to it. Okay, we can use multiple aggregate functions there. And that's fine, but we're all grouping them by P now. Got a few more of these, so let's try this one then. You'll probably need to use an aggregate function to get this. We'll use men. I guess you could possibly also sort this by manager start date and then limit the output too. That would work okay as well. Okay, for the next problem. Okay. I want you to write the plain English for what this problem, for this statement. So go ahead, pause, and think about it. You might want to even run the statement and see what it does. See if you can. That will help you figure it out. But try just looking at the pattern first. Okay. So go ahead and hit pause, and I'll show you the answer then. And there's the answer. Okay. We've got 3 underscores there, so that's taken us, or 2 underscores I should say, 1, 2. That takes care of the 19, because it starts with the year, dash month, dash day. So we're getting 19, and then anybody with a 6, and then anything after that. I think we have 2 more problems here. So let's do this next one. Okay. Going to have to do a little pattern matching with this. So go ahead and hit pause and work on that. And here's the solution. Our final problem now. I'm going to want you to write some relational algebra for this SQL statement. So go ahead and look at that, and then figure out what you think it should be. Go ahead and pause, work on the relational algebra. And here's your solution. Okay. Notice I don't have to project, because why? Well, total hours and result already have the attributes that I want, p number and total hours. And that's it for the end of this practice. Next week, we're going to start looking at how we can work SQL, work with it with multiple tables. Start doing some joins and unions, and we'll see how that works. And that's the end of this video.